Welcome to Class on the Couch. We will now be discussing chi-squared test of association. Chi-squared family of distributions take only positive values and are skewed to the right. They have one parameter, the degrees of...
There are three main properties for chi-squared distributions. First, the total area under a chi-squared curve is equal to 1. Second, each chi-squared curve, except when degrees of freedom equals 1, begins at 0 on the horizontal axis, increases to a peak, and then approaches the horizontal axis asymptotically from above. 3. Each chi-squared curve is skewed to the right. As the number of degrees of freedom increases, the curve becomes more and more symmetrical and looks more like a normal curve.
I bet you're begging to know the purpose of this test. Primarily, the chi-squared test of association is used to determine whether the distribution of one variable has been influenced by another. It's also used to test the null hypothesis when you have a two-way table from a single SRS with each individual classified according to both of the two categorical variables.
Here are the procedures for solving a chi-squared test of association. First, create a two-way table for your simple random sample. Second, calculate the expected null hypothesis count. 3. Use the secret chi-squared test of association formula. And when you do the test of association formula, you need to use the inference toolbox steps that we learned in the previous
Here we have a two-way table from example 13.9. We have one variable, smoking habits, compared to the socioeconomic status at the top of different people.
To find the expected count from the numbers in the two-way table, multiply the row total by the column total and divide it by n. And n is the number of samples in our simple random sample. And when we find the expected count, we need to make sure that all the expected cell counts are at least 1 and that no more than 20% are less than 5.
This table here is the expected counts that we got in the last equation that we found from example 13.13.
This is the secret formula for the chi-squared test of association. You take the observed value from the first table minus the expected value from the second table, square that, and divide it by the expected value from the second table for each observation and add them together, which is what the sigma says.
Now we have another example from the book, 13.12, smoking versus socioeconomic status. First, you must state the hypothesis. HO is that smoking and SES are independent. AJ says that smoking and SES are dependent. Step 2, choose an inference procedure and verify conditions. The procedure we will use is the chi-squared test of association, and the conditions are that none of the expected counts can be less than 1 and only 20% can be less than 5. From example 13.13 on the expected count slide, you see this condition is easily met.
Step 3 is to carry out the selected procedure, which is the chi-squared test of association. So we have our secret formula, the observed minus the expected squared over the expected, all added up for all the samples. And then on the next row you see the actual numbers. So the 51 is the observed minus 68.75 squared divided by 68.75 plus, and then you have all the numbers in between, plus the last sample that we have, 22 minus 25.86 squared divided by 25.86. And then you have the actual totals, what the secret formula gives you. So 4.583 plus, and then you add all the middle part plus the end part, which is 0.576, and then your total is 18.51. And when you go to the table, you need to note that the degrees of freedom is found by taking the row categories minus 1 times the column categories minus 1. So for this example, it's 3 minus 1 times 3 minus 1, which is 4.
Step 4. Interpret your results in context. Referring to table E, if I find 4 degrees of freedom, slide over to find 18.5 is between the critical values 0.001 and 0.0005. Since that p-value is so small, we can reject the null hypothesis and assume there is an association between smoking and SES in the population of male federal employees. Note that this association does not show that SES causes smoking behavior.
That's it.